Hello everyone, happy to see you here. Today we have a really interesting system of two equations. We have x plus y equal to 10 and the product xy equal to 14. We need to solve this question for x and y. So right now let's start. Of course you can easily solve this question with me right now and write your solution and your assumption in the comments below. Okay, so first of all, let's express y from the first equation, okay? As a result, y equal to 10 minus x. Okay, so y equal to 10 minus x. And right now, let's plug in it to the second equation. Instead of this y, let's plug in this 10 minus x. Okay, so let's plug in, instead of this y, this expression. As a result, we have x times 10 minus x from the first equation. Yeah, we have 10 minus x and equal to 14. Okay, and right now we have only one variable, so it's much easier for us to work with this expression. So we have only one variable, so let's solve it. First of all, let's multiply this x by this parenthesis. So we have 10x minus x squared and equal to 14. And it looks like this is a quadratic equation, but we prefer a little bit different order. We prefer a square on the first position, this expression on the second position, and constant on the third position, so equal to. Right now, we have minus x squared on the first position, minus x squared on the first position, plus 10x on the second position, and minus 14 from right side, minus 14 equal to 0. Okay, right now, a final step, because here we have negative sign. We don't like it. We need to have a positive, so it's much easier for us to work with the positive, with the classic order. And according to a classic order, right here, we need to have plus. So that's why we multiplied both sides by minus 1 equal to, so x squared minus 10x and plus 14 equal to 0. Okay, so this is our final quadratic equation, and right now let's solve it. Of course, there are a lot of methods, but I'm going to show you this one, maybe the most popular one, method of coefficients. So that's why we're gonna write the first coefficient a equal to 1 from here. So a equal to 1, b equal to minus 10, b equal to minus 10, and c equal to 14. Okay, c equal to 14. So we know coefficients, and right now let's plug in it. Let's solve it for discriminant. Okay, let's find discriminant. So d equal to b squared minus 4ac. Okay, as a result, what do we have? B squared, so minus 10 squared minus 10 square minus 4ac. So we have minus 4 times 8, so times 1, and times c times 14 equal to, okay, minus 10 square equal to 100, minus 4 times 14 equal to 56. Okay, 56. And when we subtract it, we have 44. And this is a great news for us. Discriminant is greater than 0. So from here, we have two real number roots. And in our case, we have x first and x second. Okay, so x first and x second equal to minus b plus minus square root of discriminant and all over to a. Let's plug in everything. We know everything. We know coefficients. We know discriminant. So minus b minus 10 plus minus square root of discriminant, square root of 44, and all over to a 2 times 1. Great. Right now, let's simplify right here. So two negative signs, if you multiply it, we have positive. So we have 10 plus minus. Square root of 44, this is not a table case, but we can easily express this square root of 44 as 4 times 11. This is the best way. Of course, 22 times 2 is also a case, but in our question, it's also great to express like that. In a few seconds, you will understand what I mean. Okay, all over to, and right now there is one really important and really great square root property. So we have 10 plus minus a square root of 4 times 11, so we can split it. We can write a square root of 4 times square root of 11. Okay, and right now this square root of 4 we can easily simplify it. We know it, equal to 2. So right here we have 10 plus minus 2 square root of 11 over 2. And of course, this is our answer, but I suggested to simplify this real quick. So let's factor from our numerator. Let's factor our 2. So we have 2, and in our parentheses, we have 5 plus minus square root of 11 all over 2. And right now we can easily factor these two. So we can actually get rid of this denominator. So we have only 5 plus minus square root of 11. And as I said before, this is not only one root, we have two roots, so with the plus sign and with the negative sign. So that's why let's gather all the knowledge together, and let's write our x first equal to 5 plus square root of 11, 5 plus square root of 11, and x second 5 minus square root of 11. And a lot of students might be thinking that this is a pair, but a pair is x and y. So right now we need to find y first and y second, and then we need to group it, okay? And where do we have this y? Of course, right here. Y equal to 10 minus x. This is our first line from the after this question. So we have first line, and we really need this right now. Y equal to 10 minus x. So let's remember it. Let's write but y equal to 10 minus x, 10 minus x, and let's solve it for y first. So y first equal to 10 minus x first, okay? And right here we have the same thing. So y second equal to 10 minus x second, and we can easily solve it. We have x first and x second. So that's why y first equal to 10 minus 5 plus square root of 11, y first equal to 10 minus 5 minus square root of 11. So y first equal to 10 minus 5 equal to 5. So 5 minus square root of 11. So we have this is like a symmetry. We have a symmetrical answers. 5 plus square root of 11, and the second answer 5 minus square root of 11. And we will have absolutely the same thing with this second case, but let's check it. Y second equal to 10 minus x second, 10 minus 5 minus square root of 11. So y second equal to 10 minus 5 plus square root of 11, and from here y second equal to 5 plus square root of 11. So as you can see, we have two symmetrical pairs, two symmetrical answers, and right now let's gather all the knowledge together, and let's write our final answer to this question. Let's group everything. So we have 5 plus square root of, so we have a pairs x first, y first, x second, y second. So 5 plus square root of 11, this is our x first, square root of 11, and 5 minus square root of 11, 5 minus square root of 11. And second parenthesis, 5 minus square root of 11, yeah, this is our second pair, and 5 plus square root of 11, 5 plus square root of 11. So we have two pairs, and right now let's check it. So in the end, let's check our pairs, and we have really interesting situations because we have x plus y, this is our question from the beginning. We have x plus y equal to 10, and xy equal to 14. We have really interesting situation because we have addition and multiplication, and to be honest, according to mathematics, we don't need to check both of these answers. We don't need to check, for example, both of these, because we have addition and multiplication. X plus y, this is the same as y plus x. So that's why we can easily choose, for example, this case, these pairs, and we can check it. We don't need to check this one because this is like a symmetrical things, and we will have absolutely the same answer. So in terms of addition, let's check these pairs. So 5 plus square root of 11 plus 5 minus square root of 11, okay, equal to. We can easily cancel this square root, and we have 5 plus 5 equal to 10. And this is our first equation. This equation is great for us, so we can easily say our root is great. And right now, let's check the second equation, xy equal to 14. So that's why we have 5 plus square root of 11, and multiplying by y equal to 5 minus square root of 11 equal to, this one need to be equal to 14, okay? And from this perspective, this is a difference of squares, because if you remember this really tricky and really important and of course really popular formula, when we have a square minus b square, this is equal to a plus b times a minus b, okay? A plus b times a minus b. Difference of squares. We have a plus b, a minus b. So this is a difference of squares. So you do need to multiply parentheses by parentheses. So we have 5 square minus square root of 11 square. So equal to 25 minus 11 equal to 14. And we have exactly that case right here. So addition works perfectly, and multiplication works perfectly as well. And of course, this is our answer, and everything is great. So I really hope you understand my solution. I really hope you understand my explanation. It's extremely important for me because my main goal is to make math understandable and popular for everyone, and I really hope you enjoyed this solution. But if you still have any notes, if you still have any questions or assumptions, you can also write in the comment section, and then we will check our answers. It will be really interesting to discuss a little bit, and maybe this question is for students mainly, because for teachers it may be like a very easy question. Maybe you're preparing for exam and this question is great for teacher, but mainly I do this video for students because maybe a lot of students have problems with the system of equations. They don't know about methods. How can we do this? This is one of these method. Yeah, we have it. Method of we express from the first equation and plug it into the second equation. And if you have problems with the quadratic equation, you can also pause the video. So this is like a great question for students, first of all. Yeah, and I solved it step by step, so that's why maybe this video is a little bit longer than the previous, but I want to solve this question step by step because I received a lot of messages, a lot of comments that I explain so fast, and that's why I do this step by step, and I try to explain in an easy way, with an easy words, because it's extremely important to learn something after the video. So thank you for your time, have a great day, see you in the next videos, and take care of yourself.